Well, good afternoon, and thank you for coming to my talk today. I hope everyone's having a great time so far at the PDC. I'm very excited to be here today to talk to you about what's new in VisualBasic.net. Let me ask you this. How many times have you been reading a magazine or a news group, or you talked to your coworkers and you heard, VB is not a real development tool. It's a toy. Everybody heard that? All right, a lot of people, good. Well, I've heard it too. Today, I'm going to show you that VB is a real development tool. I'm going to show you how we fixed a lot of the the inconsistencies and problems in the product. And I'm going to show you how we're delivering on a lot of the great features that you've been asking for over the years. My name is Chris Dias. I'm the Group Program Manager for Visual Basic at Microsoft. Before we get started today, I have a little story. So last night I was having dinner with the Group Program Manager of Visual C. Come to find out, those guys were right next door. They're doing the talk, What's New in VC++. And he bet me that he could get that crowd more excited and making more noise about VC than I could get this crowd about making noise about VB. So today, if you hear something that you like, let's hear it. Let the VC guys hear it. And let's get started with a few slides and some great demos. So, you guys are easy. This is what we're going to talk about today. Every time we release a new version of the product, or we start a new version of the product, we set out some design goals. It helps us to motivate and to drive hundreds of developers and testers and program managers like myself, so we can develop and deliver a product that we think fits your needs. So I'll show you with the design goals what we started out to do, and you can see as I unveil the features in the product, you can see how we met those goals and how the design goals let us meet your needs. We're going to talk today about how all of the tools are integrated into Visual Studio, VB, Visual InterDev, and how they all fit together. Over the past couple of days, you've heard a lot about the .NET framework, and you've seen a lot of the applications that can be written on it. I'm going to show you how the .NET framework relates to VisualBasic.net, and I'm going to show you how you build applications in VB.net using the .NET framework. Now, I absolutely love the basic language. I love it. It's good because my job description, that's what I have to do. We've taken the time in this version of the product to make sure that the basic language is ready for another great decade of application building. With every release of the product, one design goal is to be the best tool for developing applications on the platform. With VisualBasic.net and VisualStudio.net, we want to be the best tool for building .NET applications. You've asked us for inheritance. You've asked us for stricter type checking. You've asked us for a new menu editor. You've asked us for lower TCO. You've asked us for a lot of new features. And you've told us about the types of applications you'll be building in the future. We want to deliver VB.net that delivers on those features and enables you to build your next generation of application. So did you know, or did you realize, that Visual Basic is coming up on its 10th anniversary? Over the years, we've added a lot of new features to the language. With this version, we wanted to make VB a truly modern language. You've told us that VB's great, but at times you hit a wall. You can't do something in VB. VB hides so many of the intricacies of Windows applications that when you do need to get under the covers, it's hard or it's impossible. You have to go to another language. With Visual Basic.net, we want to remove that wall. We want to give you full access to the framework. So in this release, finally, in Visual Studio.net, all of the languages and all the tools are in the Visual Studio environment. When we were looking at the types of applications we wanted to enable building in VB and VC, we said, you know, we need all of those great features of Visual InterDev. So instead of duplicating VID's features throughout the different languages, we integrated Visual InterDev into Visual Studio.net. So all of the tools, all of the languages get VID's great web development features, the rich HTML editing, web projects. You can open up a web project in VB and VC now. And answer your next question, yes, you can open up Visual InterDev projects in Visual Studio.net, maintain them, create ASP pages. But now you get the option with ASP Plus and web forms to write compiled code that runs on the server instead of script. Visual Basic.net brings RAD, or Rapid Application Development, to Visual Studio. In fact, everything that I talk about today, except for the language itself, applies to C# as well. All of the great design time features, the drag and drop, the F5, applies to all the tools. Everybody gets VB's great RAD features that we've always enjoyed. For Visual Basic developers, Visual Studio.net brings a wealth of new features to us. We have a new common file-based project system that enables us to have multiple language projects and solutions, not projects, solutions. So I can have a control written in C# and a Windows application written in VB, open at the same time in the solution. I can drop the C# control on the VB form, hit F5, debug all the way through it. The focus of .NET applications is really distributed multi-tier applications. And Visual Studio.net lets us easily debug cross-machine multi-tier applications. I can step from the client across a web service to the middle-tier business object, and from the business object to the database into the Transact SQL, and all the way back again. How many people write code and you're plugging along and you stick in a comment that says to do or hack or undone? Visual Studio will identify all of these, list them in its task list. You can go back easily to your code by double-clicking the task list, jump back to your code, and finish the job. The task list also shows multiple compile errors. In VB6 today, you hit F5, you get a compile error, you fix it, you hit F5 again. With Visual Basic.net, all of your compile errors are shown. And as you fix them, they go away. So even before you hit F5, you know that you've hit a lot of the compile time errors. So this integration of all the tools into Visual Studio really is going to make your job easier. VisualStudio.net and VB.net and all the tools are going to let you focus on the problem you're trying to solve, not on the implementation. So you build applications in Visual Basic.net using the .NET framework. When you build a web application or a web service, you're using system.web. When you build a Windows application, you're using system.winforms. The design time experience for building these applications also comes from the .NET framework. So there's a tight integration between design time and runtime. So you drag controls onto the form. You're seeing the .NET framework there as well. It's simply hosted inside Visual Studio. Now, when you want to access system services like File I/O, or you want to do data access with the ADO+, using the base classes from the .NET framework. And the Common Language Runtime is just that. It's the runtime for all the languages, including VB. All of the memory management, all of the object lifetime, everything that the VB runtime took care of in VB6 and the previous versions is now handled by the Common Language Runtime. This means there's no more MSVB, VM 60 or 50 DLL. There's no more VB run DLL. The other great thing that the Common Language Runtime gives us is a common type system. A Boolean in VB is a Boolean in C#. The structure in VB is a structure in C#. Any language that's on the Common Language Runtime shares the same data types, so you can interoperate seamlessly between languages. So if you think about it today and you're trying to pass a Boolean to a DLL, it just gets hairy. But with a Common Language Runtime and the common type system, you don't have to worry about that. You just pass the Boolean. So what all of this gets us is tight integration with the platform, with the framework, consistent behavior between all of the tools, and interoperability between all the languages. I actually want to mention one other thing that I forgot to mention. When you build applications and you use system.web for web apps or use system.winform for Windows applications, and you're building a form in VB, if you go over to C# in VC and you build the same form, the forms are the same. VB today has a proprietary forms package. A lot of the tools have their own forms packages today. VC has their own. They don't interoperate. I can't take a form in VB and pass it to a VC project and expect it to work. But because all of the languages use the .NET framework, the forms are the same. I can share them. They interoperate. So just another example of the great interoperability we get between all of the tools. So this week you're going to hear a lot about web forms and ASP+. The thing to remember is that web forms is a part of ASP+. ASP+ gives us the web application model. It gives us the entry points into the application. Global objects like request and response. It gives us a processing pipeline. It also gives us web application services like state management, authentication, caching. It also gives us scalability in its architecture. ASP+ gives us the robust foundation for building web applications at scale. Now, if you're familiar with web classes in VB6 today, you can think of web forms as the best of web classes combined with the best of traditional ASP. So with web classes, your code runs on the server. An event that you cause on the web page fires on the server. With web forms, it's the same thing, but you get a rich HTML design surface. You get table and frame set editing. You get all of the great design features that you have when you're building a Windows application, but building a web application. So when you're dragging controls from the toolbox onto a web form, the only difference between designing a web form and the Windows application is now you're designing HTML. You have complete control over the HTML that's sent down to the client. I can send rich HTML 4.0 or reach HTML 3.2. You can even target devices with WAP. Another great thing about web forms is that it separates the UI from the code. So the HTML page is in one file. The code behind the HTML page is in another file. You can hand off that HTML page to your graphics designer. And you can leave the coding to your developer. You can create multiple language templates for your HTML pages and use the same code. So it all works well, and it makes it very easy to create scalable applications that run on the web, rich scalable applications that can then target any browser or any device on any platform. So the next piece of UI that UI that we have in Visual Basic.NET is WinForms. Now, WinForms are used when you create a Windows application. They replace today's forms in VB. WinForms is a framework. It's extensible. I can inherit from it. I can override it. It's a very clean implementation of what we expect in a great forms package. And it's very extensible in the future. So let me give you an example of what I mean. Can we flip over to the demo? So here's VB6 today. If I put a button on this form, everybody knows that it's got a help context ID. So we have help context IDs on all the forms and all the controls. It's originally designed for WinHelp. Win95 came along, and they introduced What's This Help? So we added the What's This Help property. HTML help came along. We overloaded these properties to support both WinHelp and HTML help. Unfortunately, that puts us kind of in a pickle. And you, in your application as well. So you don't need help in your application, or you don't want help. Your applications have it anyway. Or if only some parts of your application use What's This Help, you still have it. Now, WinForms fixes this with the idea of extender controls. An extender control is placed on the design surface, and it attaches itself to the other controls. So in WinForms, if I look at a button, so I flipped over to Visual Basic.NET, Visual Studio.NET. Here's WinForms, and I have my button. You'll notice there's no help properties here. What I can do is come over and drop the help extender provider control. If I go back to my button, I can see that I now have help on that control. It's the same for other controls. So what's great about this is that I can add help to the forms that I want. If I want to clean up my application to delete all of the help, I just delete the extender control. And now it's gone from the control. And if in the future, let's say 5 or 7 years from now, some other new help technology comes out, instead of overloading the properties even further, we can just produce a new extender control. And then you can go ahead and take advantage of the help when it comes out. So the last bullet point on my slide says WinForms has an in-place menu editor. And this is true, but really the bullet on the slide is a placeholder for a number of features that WinForms fixes in the forms today. For example, you want to add scroll bars to your form? In WinForms, you just set a property, auto scroll, and they're automatically added to your form. How much resize code do you think you've written in your lifetime? It's never the same either, is it? You're always tweaking that last couple of numbers. Well, WinForms has a bunch of properties, docking and anchoring, that virtually eliminate the need to write resize code. And of course, if you ever wanted to visually inherit from a form in VB, well, you can in VisualBasic.net with WinForms. So let me show you that. So I've got a project that I've been working on. It's a wizard. And I have the base wizard form that I created. So this is my base class. I've got some controls on here. They're protected. I've got some code behind the buttons. I've got them marked as overridable. So when I derive from the class, I can override it if I want. The first thing that we want to do with this project is add the last step. So we'll add an inherited form. We'll call it step 4. We'll say we're going to inherit from form wizard. We'll add it to the list. So now as we bring up step 4, we can see that it's inherited from the base class. The controls on the base have a different color because they have different modifiers, protected or private or public. But this one's protected, so what I can do is come over here and simply type in and press finish. Okay? So the control's there, it's positioned properly for me. I just override the text property. Another thing that I want to do is give the ability for the user to view a summary report. So I'll add this to the control, to the step. And I'll double click and write some code. I have a summary report already created. So let's run this, make sure that everything's working okay. So you can see I can step through it, and there's my final page. Let's work on the summary report window for a minute. Really all I want to do in the summary report is put up some text, but I want the form to look nice. So I'll put a rich text box on here. I don't want to write resize code. So I'll go to the dock property and say dock this to the top of the window. And I'll put a button on here to close the form. And I actually want to anchor this button to the lower right-hand corner of this form. So when it's resized, the button stays in its relative position. So when I drop down the anchor property, I say the right-hand side and the bottom. And you can even see that at design time, the button now sticks where I place it with the anchor. Well, because I'm a good UI programmer, I want to add the ability for the user to save out this report. So I'll put a menu on here. Here's the new menu editor. File. Save as. I want to save as dialog. So WinForms also just has the common file dialogs right on the toolbox. So I'll drop one of those on there. Write some code. So the last thing I want to do is, the font on this form looks pretty bad. So you know what happens today in VB. So you've got to select all of the controls and set the font on each one of them, and not all of the controls get the font to show up. But what I can do in WinForms is just set the font of the form itself, and all the controls will automatically pick up the font for me. So let's run this, make sure everything's working okay. Yep. Resizes, file works. All right. So there's a couple more things that I want to do. On this step of the form, I ask the user to give me a project name. But I want to do a little bit of validation before they move to the next step. So what I'm going to do, you can see what we've got here, is I'm overriding the click event of the base class. So I can go in here and add some of my own validation code. And if everything's okay, I'll delegate down to the base. So say if text box project name set focus to it, and exit sub. So if there's nothing in there, it won't proceed to the next step. We try this out. Great. And it moves on. So we've overridden the event, we've done our own code, and then we've delegated down to the base class. So the last thing I want to do is go back to the base class and add a cancel button that I want all of my forms to pick up. So I'll add a new button. Set its property to cancel. You can see it's private. No one's going to be able to override this. And all I have to do now when we run this again, all of the forms in the wizard will pick up this class. Okay? So anywhere in here I can click on cancel and the application ends. That's some pretty cool stuff, isn't it? I love that. Okay. Can we flip back to the slides, please? So if you remember back to the days of VB3, 2, and 1, we had VBXs. VBXs were really the first instance of code reuse. It was visual reuse. VB4, we moved on to a more formalized reuse in COM. Not only could you reuse controls, but you could also reuse your business objects or your code by exposing them as objects. Any COM-aware language can create and consume these. The third generation of code reuse is with web services. Now, any developer on any platform can reuse code through web services. So you've seen a lot about these things in the past couple of days. But what I want to tell you today is that creation of web services in Visual Basic.NET is easy. It's very easy. All you do is you mark a public function with an attribute, and you say that it's a web method. Now, an attribute describes your code to the compiler and to Visual Studio. So when you build that application, the compiler and Visual Studio see that it's a web method. It turns around and produces the XML, publishes it to the web for you, and once you're done, your web service is now universally available. Consuming web services is very easy as well. You can make a reference to a web service just like you make a reference to a component today. You can use a new tool called the Server Explorer and browse for web services. When the tool sees a web service and brings it in your project, it automatically creates an object for you that you can program against. It's got properties. It's got methods, which are the same functions that you expose in your web service. It's got return values. And to use them, you simply declare an instance of the object and call a method on it. When you build applications today in VB, you drag and drop controls from the toolbox onto the form. I call this the composition method, right? You're composing your form. With Visual Basic.net, we've taken this metaphor of composition and extended it to classes. So now you have a visual design surface for classes. You can drag and drop components from the toolbox onto your class and graphically build up your business objects, set properties, double-click, and write some code. But building server components isn't just about writing code. It's also about working with your server resources. You need to create message queues. You need to get your database. So to solve these problems, we have a new tool called the Server Explorer. Now, the Server Explorer is a programmer's tool. It's not an administrative tool. It doesn't replace the management consoles that you find in Windows. You can point at a machine, connect to it, drill down, and see all the different resources there, like event logs, message queues. If you've got databases on the machine, you can drill down into it. You can think of it like the data view today in VB6, only stepping back one level. So instead of pointing at a database, you point at the machine. You've told us that it's very difficult to diagnose and configure your applications once they're in production. It's just hard. For example, let's say I build an application, it uses a message queue, and I'm sending messages to a particular queue. It's out, it's running. 3 months later, the message queue location changes. What do I have to do? To take the application down, open it in the tool, change the property, rebuild it, redeploy it. The .NET Framework introduces the feature called dynamic properties. What dynamic properties are essentially a configuration file for your property values. So what I do is in Visual Basic.net, I specify that the path property of that queue is dynamic. So the value gets written out to a configuration file. It doesn't get burnt into my executable. And when I deploy this application, I also deploy the configuration file. So in 3 months, when that queue changes, I don't have to bring the application down. I just update the configuration file. The application automatically picks up the changes and starts firing off to the new queue. The .NET Framework also has a tracing feature. So in your production applications, you can actually compile in trace diagnostic messages that get turned on after the application is deployed. The overhead is completely minimized by the runtime itself, so the only performance hit you take is when you turn on tracing. So your application is in production, it's running, there are some problems. Somebody submits a bug. What you can do is turn on tracing, and you'll start getting your diagnostic output, and you can narrow down where the problem is in the production application. You can then go back to the design environment without taking the application down, fix it, and redeploy it. So all of these features, together with efficient scheduling of code, easy access to message queuing, the ability to create traditional NT services in VB, combined to make it very easy to create scalable server components. So let's take a look at some of this in action. Can we flip over to the demo? So let me set up the scenario beforehand. I've got a website which I developed in VB, which lets me order flowers online. It's called Market Florist. And what we can see here is I've got a selection of products I can order. I can click on Add to my shopping cart. Then I can click on the shopping cart page, see everything in my shopping cart, and check out. The problem right now is there's nothing behind this Checkout Now button. So what I want to do is write the middle tier business object that handles placing an order to Market Florist from this website. So the first thing that I'm going to do is create a web service. And the web service is what's going to actually accept the order. So I'll create a new web service project. We'll call it Market Florist Web Service. So the first thing that I really want to do in this web service is I kind of want to put it together a little bit, make sure I get everything working right, and then we'll expand on it, kind of the way you build things in VB today, right? You try it out, and you keep expanding on it. So what comes up first is what we call the Class Composition Designer. This is the visual design surface for your class. What I can do, the first thing I'm going to do is send messages to an incoming orders queue. So we have the Server Explorer. I can drill down the VB Demo 12 machine. I don't know if you can see that, but this is the machine that we've got. I can drill down further into message queues. We can see that I've got 3 queues defined in this machine. So I can drag and drop the incoming orders queue, double click, and now I'll create my web service. And here's the attribute, web method. This is going to mark it. It's going to tell the compiler in Visual Studio that this is a web service. Okay, so we're going to accept a string, which is really just the contents of the order, and we'll return a Boolean to say whether or not it was successful in actually taking the order. Use some structured exception handling. Wow. Okay. So we're going to send the message to the queue. We'll return true. If it fails, we'll return false. We'll save this and build it. We'll hit F5. Now for a minute, if you think about hitting F5 on a web service, what does that actually mean? Because really, I've just published a set of interfaces up to the web. Now someone has to call them. Well, what we do is we make debugging and trying out your web services a lot easier. We produce this web page which shows you all of the public web methods in your web service, and you can come down and actually try them out. So I'll just pass in roses here. We'll invoke it, and now we get the return value, which is true, so it was successful. I can go look at the message queues on the machine and make sure that a message actually got to the queue. Great, so incoming orders has 1 message in it. So let's make this business object a little bit more interesting, okay? Not only do I want to send it to the incoming orders queue, I'm going to send it to the accounts receivable queue as well, and the pick list queue. If I encounter any errors in my business object, I want to write them to the application event log, so I'll drop an event log on there as well. And of course, I want to see how well my business object is running. So I'm going to use a performance counter to track the number of orders that I process. So I've got a market florist counter already set up, number of orders. I can drag that on there as well. So let's finish up our code. We'll send to the other queues. We'll update a performance counter. Increment by 1. And we'll get out. Now, if we have an error, and that's it. Okay. So then let's go ahead and hook this back up to our Market Florist website. So I'm going to open up the Market Floors project now. And we'll update that shopping cart page with the code to the web service. But the first thing that I have to do is get a reference and bring the web service into this application. So I'll go to the Server Explorer again. I'll drill down. The Server Explorer will actually do web discovery for me. It'll go to the machine and it'll find all of the web services that are out there. And here we go. We can see my Market Florist web service. I'll right-click and just say Add to Market Florist. So what this is going to do is go ahead, read all the XML off the web, create an object that I can program against in my project. So now once we're done here, I can open up the shopping cart page and write the code to go against my web service. So here's the page you saw online. Here's the Checkout Now button. And you can see this is a regular button with regular compiled VB code that runs up on the server. So to call the web service, I just say dim new web service. Since it returns a Boolean, I'll say if web service order flowers. And I've already written the code to take all of the cart and package it up into a string. Say order contents. It's true. And then I'll update the page and send a nice message to the customer. And if this fails, we'll let them know as well. Okay. We'll save that. We'll run the Market Florist website again, see if all of this hooks up. So what do you think so far? Pretty good? Okay, we'll order the springtime bouquet and the holiday basket. We'll go over to the shopping cart, and you can see that they're there. We'll click on the Checkout Now button. It's going to go up, call the web service, and send the order to the queue. If we go back and look at the queue now, something. Anyways, you can see that the orders are being processed. The other interesting thing that we can do is also see the performance of this service. So I'll open up Performance Monitor. It's the Market Florist counter. We'll add it. You can already see that it has a value of 1. So as I add orders, and the system processes them, anyways, what would happen in an ideal situation? I honestly don't know what that error message was that came up, something about the event log being full. When I enter the orders in, we go out and we call the performance counter, and you can actually see the chart scaling up as we do the orders. So it's very easy to create these middle-tier business objects. And we filled out part of the application. So let me close this down. So can we flip back over to the slides for a minute? Okay. So data, ADO+. ADO+ is a natural evolution of the ADO that we know today. It's got a command object. It's got a connection object. The difference is ADO+ is designed for scalable, distributed, multi-tier applications. You've told us that when you build applications in VB today, they don't scale because VB's defaults don't scale. The data control doesn't scale. When you build applications in Visual Basic.NET, they use ADO+, they use the right architecture, so right out of the box, your applications scale. Datasets are core to ADO+. They're disconnected caches of your data. They don't know where the data came from. They don't know where the data is going. They simply contain the data, changes that you've made to the data, and any schema to describe the data. Data sets are inherently XML. They persist as XML. They're passed across the wire as XML. The schema is XML. So by default, because everything is in XML, it interoperates. Now, data sets are disconnected by design. You define how the data gets into the data set. You define how the data gets out of the data set. When you write data access code today, usually it's in the format of record set, .rows, .fields, .values, and it's a very labor-intensive thing to do. You don't get statement completion. You don't get valid data types. With ADO+, your tables are actually objects, what we call strongly typed objects. So instead of saying record set rows sub 1 fields open quote last name value, you just say customer last name. You get statement completion on all the fields in your database. You get the right data types. The best thing is you get compile time errors, right? So there's nothing worse than running through your data application and realize you've got the wrong index somewhere in the fields collection. But when you program against objects, we know about it ahead of time, so we can flag it before you even go into run mode. Another thing that you've told us is that you don't like all of the magic that happens when the data is updated to the database. Right? Today, with the ADO, and you issue an update record, the update method on the record set, it goes off and creates a bunch of dynamic SQL statements and updates the database for you. You told us you want control over that functionality. Well, ADO Plus and data sets give you that control. You specify the SQL statement that you use to update the database. Or better yet, you specify the stored procedures to use to update the database from the data set. So you have full control over the data. So speaking about XML, as you know, XML is what allows us to have all this great interoperability. The great thing about Visual Basic.NET and Visual Studio.NET is that without you even doing anything, the tools produce and consume XML by default. So like I said, your data sets are XML. When you create a web service, the interfaces are XML. When you do object persistence, it's persisted as XML. When you send something to a message queue like we did in this demo, it's done as XML. So inherently, your applications interoperate because they're using XML. Now, let's just say that you do want to go ahead and do XML. So we make that easy as well. So instead of using Notepad to manually type out your XML, the schema, and the data in there, you can use the new Visual XML Designer. You can drag and drop components from the toolbox to define your schema. You can enter data into your XML file with an Axis-like table editing view on the Visual Designer. You get IntelliSense on your XML. So once you have the schema set up, you can actually go in and you'll get statement completion on it. If you really want to get down to the metal, the .NET Framework has system base classes that you can use to get full access over the XML. So let's take a look at some of the data features in another demo. Can you flip over the demo machine, please? So let me just start up SQL Server here. Now we're going to continue building the Market Florist website. We just added the functionality to purchase the orders online. Now what I want to do is add the functionality so that I can go and actually view all of my previous orders that I've placed with Market Florist. So I want to fill out this page, the My Account page. There's nothing there right now, but what we're going to do is build this. So we'll open up the Market Florist project. We'll open up the My Accounts web page. Now the first thing that I'm going to do is add an ADO dataset command to my form. Now the ADO dataset command is the object that I use to push data into the dataset. Okay? So I have a command on there. I'll choose configure. We'll run through a wizard. We'll make a connection to the database. It lets me choose how I want to go get the data. Use a SQL statement. It'll create stored procedures for me, or it'll use existing stored procedures. I'm just going to use a SQL statement for now. And now I can either type in the SQL myself or bring up the query designer. So we'll look at the account history table, select all the fields, run it. Looks great. I've got my data. We'll move on and finish the wizard. Now, what the wizard's going to do is start working backwards from this object. It's going to create a connection to the database for me. One thing that I have to do here is the web page itself has a property called generate dataset command, dataset. So I'm going to set this to true. And what this is going to do is force the tool to go out and build that strongly typed object that I talked about, as well as the data set that we're going to get the data from. I have to drop a data view onto the form. The data view is a cursor that's plugged onto the data set that lets me do the scrolling, the finding, and everything like that. We'll say it's going to go against the account history table. So now that I've got that set up, I simply need to go and drag a data-bound grid onto my web form. I'll stretch it out and make it look nice. We'll set the data source property to the data view. And the last thing that we do, we have to write a couple of lines of code. Fill dataset at dataset 1. Now, fill dataset is a line of code that I write that says, hey, go get the data from the database and stuff it in the dataset. Right? Like I said before, ADO Plus gives you complete control over how the data comes in and how the data goes out. And then I write the line of code datagrin1.databind, and we're done. So we'll run this. We'll go to the My Account page. And there, we've got data. Okay. So can we flip back to the slides, please? So you've heard it before. You've told us about it. We've heard it. You know, BASIC is not an object-oriented language, right? Sure, it's got object-oriented features, but it's not an object-oriented language. Well, in Visual Basic.NET, BASIC is is an object-oriented language from the ground up. We didn't simply take inheritance and tack it onto the side and call it a day. We integrated it. We made it a core part of the language. The great thing about the .NET framework is that inheritance is not limited to things that you create in BASIC. In C#, I can inherit from an object written in BASIC. In BASIC, I can inherit from an object written in C. Why this is great, because you can go out and create your own frameworks. You can create your own controls. And then in VB, you can override them. You can inherit from them. You can extend them. But we didn't stop there. To make VB truly modern, we added modern programming constructs. So now we have structured exception handling. We have real parameterized constructors and destructors. You have nested classes. You can have multiple classes in the same source code file. You can have multiple modules in the same source code file. You can initialize variables when you declare them. You say dim x is integer equals 5. You can even initialize arrays when you declare them. So if you dim an array, you can pass it the entire contents of the array. With the .NET framework and a few language constructs, multi-threading is easy in Visual Basic .NET. You can create multi-threaded, three-threaded applications. It's as easy as creating a thread object and passing a delegate to it. So now a delegate can be thought of as a function pointer, only it's object-oriented. If you think about what we have in VB6 today, we have address of. That gets you a function pointer of functions defined in modules. A delegate will get you a function pointer of functions in modules as well as methods and classes. You can pass a delegate around. You can invoke the function using the delegate. It has an invoke method. So you can write code that takes a delegate as a parameter. You don't know what the function's coming in, but you can call it anyway. So in comparison to VB6, where you could get the function pointer and that was it, the delegate gives you the ability to get the function pointer, pass it around, and invoke the method. So when you do multi-threading, you create a thread object, and you pass in a function pointer to the function to run on that thread. If you step back for a moment and you look at the basic language as a whole, you find a great language, but you also find some inconsistencies. Dim x, comma y, comma z as integer has never given us 3 integers. In Visual Basic .NET, dim x, comma y, comma z gives you 3 integers. We've simplified the property procedure syntax, which is perhaps the only use for the tools add procedure dialog. We've removed some long since forgotten constructs from the language. For example, def type is gone. So if you're scratching your head and you're trying to remember what def type is, it lets you define a range of variables as a type. I'll take questions at the end. So I could set up something like all my variables that begin with the letters A through E are integers. Variables beginning with F and G are longs. Well, this was great in the days of DOS basic programming to save some memory. In Windows applications, it really just makes for more bug-prone code and harder to maintain code. You've told us you hate evil type coercion. This is where we try to change the data types for you when you do assignments or concatenations or calculations. While this is useful when you're rapidly prototyping an application, it can quickly lead to subtle bugs that are very hard to find and hard to fix. So we fix this with what we call option strict. It's on by default. We don't do the coercions for you. You have to explicitly do them yourself. We're very serious about this, so much so that to turn it off, you have to write a line of code. So with Visual Basic .NET, BASIC is now a modern, more robust, more bulletproof language. You can write more maintainable code. But it's still the language that you already know for writing the next generation of applications. So you've told us, and our own internal build labs have told us, that it's next to impossible to set up an automated build process for VB applications. VB6.exe has a couple of command line switches that you can automate. You have some control over version information. But if you want to change files in the project, you've got to script the project file and then do the build. Well, with Visual Basic.net, we have a new command line compiler called VBC, Visual Basic Compiler, VBC.exe. This compiler gives you total control over the build process. You pass it source files, not project files. You pass it resources. You can script an entire build process by giving it a response file, which, oddly enough, is the name of the input file. VBC does not process project files. When you do a build in the environment, a lot more happens than just a compile of the code. For example, when you have a web service, another process runs where we produce the XML and we post it to the web. So to fill out, to round out all of the features that happen when you do a build in Visual Studio, the .NET SDK has a number of other command line tools that, again, give you fine-grained control over the entire build process. If you do still want just a regular old build of the product as the environment does, you can call devm.exe/make or build. So these tools together make VB a very powerful development tool, even for build labs. So you've built your application, your new .NET application. You've tested it out on your machine. Everything works great. Now comes the hard part, right? The combination of the .NET frameworks and Visual Basic.net make deployment easy. In previous versions of VB, we've shipped our own custom setup technologies. Package Deployment Wizard, the Setup Wizard. And these work for the most part, but you eventually run into some problems where you have to go modify Setup 1, or you have to use a third-party tool like Install Shield. The Visual Studio installer builds Windows installer setups. This means you get all of the great features of the Windows installer, like incremental download, signing of your setups, advertising, self-repairing setups. When you do multi-tier installations today, this usually means running from server to server to server, running setup on each one. And if you have to create some additional server resources, such as creating a message queue, you have to pretty much do that manually. Well, the Visual Studio installer builds setups that will deploy multi-tier applications to different machines from one location. So if I run setup from this machine, it'll install the web application on the web server. It'll go out and it'll create the message queues for me. In fact, with the Visual Studio installer, I can create my own custom installers so that I can essentially run code during installation. And the great thing about Windows installers is that it's transacted. So if something fails during the installation process, you can roll it back. So if you're writing your own custom installers, you get notified when setup fails, when you have to roll back, or when you have to commit. It's as easy as subclassing a base and filling out the appropriate methods. Now, probably the most exciting deployment features are enabled by the .NET framework itself. No longer do you have to restart IIS when you deploy a DLL to the web server. Excuse me. You can X-copy your applications and they'll run. You can install applications into a single directory. You can delete applications by deleting the single directory because there's no registration involved. You can install applications side by side with different versions and run them side by side, and they won't impact each other. So all of this really makes for a great deployment story. It really lowers the total cost of ownership for your applications. using the .NET framework in the Visual Studio installer. So by now you're thinking to yourself, geez, Chris, this stuff is great. I love it. But what about my existing projects? So with every version of VB, we do some sort of conversion on your projects from the previous version. The same thing is true for this version. We'll open up your VB6 projects in Visual Basic.NET. It will run through a conversion. The difference is this time you're going to have to rewrite some code. So the first thing that happens is we copy your project because you can install VB6 and Visual Basic.NET on the same machine, and they can run side by side. So we protect your existing project. And then we go ahead and we migrate the technologies. Your forms are migrated to WinForms. Your web classes are migrated to web forms. The syntax in your code is migrated where the changes happen. So like I said, some code does need to be rewritten. If you're using def type statements, they don't exist, so you're going to have to work around that. There may be cases with late binding where we can't determine intent. What we do is we mark those lines with to-do comments. They show up in the task list. You can easily go back and figure out what changes you need to make. ActiveX documents don't migrate forward. DHTML pages don't migrate forward. The data report doesn't migrate forward. We're going to produce a detailed list of everything that does and does not migrate forward as we get closer to shipping. We're going to produce white papers. We're going to produce courses, books, samples. We're going to do everything we can to get you the information that you need to plan out your migration strategy. So, in summary, you've asked us for a number of features. We've heard you, and we're delivering on them. We've got inheritance. We've got multi-threading. We've got rapid web application development. We've got an integrated environment. You have full access to the .NET framework. No longer do you need to make a language choice based on need, but on preference. Even though there's a lot of new changes in the product, your skills and your investments are going to move forward. The most important thing is that VB, Visual Basic.NET, is ready for an entire new era in application development. When you get the PDC CD, install the tool, play with VB. Let us know what you think about it. Thank you. So I'm over my time limit, so we can't take any questions. But we can meet down here, or we can talk at the booths, whatever you want to do. Thanks.